Welcome to Math 120, Intermediate Algebra at Doña Ana Community College in Las Cruces, New Mexico. We're using Turner-McKeag Intermediate Algebra. It has a really awesome parrot on the front. Chapter 1, Real Numbers and Algebraic Expressions. Section 1.2, Properties of Real Numbers. Alright, so the commutative property. Think of it like commuting to work. You drive back, you drive home. Alright. Let me say that one more time in a better way. You drive to work and then you drive back home, right? So in symbols, A plus B equals B plus A is the addition commutative property. In words, the order of the numbers in a sum addition does not affect the result. So 3 plus 4 is the same as 4 plus 3. This does not hold for subtraction. Subtraction order matters. Addition, either order is fine. Similarly, in multiplication, the order of the numbers in a multiplication doesn't matter. Whether you're going from home to work or from work to home, it's the same thing. So A times B, B times A, same thing. Not true for division. So the addition and multiplication properties are commutative, but subtraction and division are not. The associative properties, how do they associate with each other? So if you have A plus and then the quantity B plus C, and it's all addition, that's fine. You could add A and B first and then C. You could even add A and C and then B. So the order that we add values in doesn't matter as long as we use each number once and we add them all together. Similarly for multiplication, whether you're on the outside and your friends are hanging out or you're hanging out with one friend and the other one isn't there, it doesn't matter. When you multiply, you can multiply B times C first, parentheses, and then times A, or you can multiply A and B first and then C, or you can multiply A and C and then B. The grouping of the numbers in a product, so in a multiplication problem, does not affect the result. As long as we're using multiplication and we use each of A, B, and C only once, it's all good. The distributive property. This is the property that combines the addition and multiplication. So we say that multiplication, A times this quantity, B plus C, distributes over addition. So A will get multiplied by B, and A will get multiplied by C. Multiplication distributes over addition. Let's talk about a few definitions. First of all, similar terms. Similar terms are terms with the same variable part. So we don't care about the number part, we care about the variable part. If we take a look at 3x and a negative 17x, they're similar because they both have an x. Doesn't matter that one's positive, one's negative, doesn't matter about the 3, the negative 17. The variable part, x, is exactly the same, so they're similar terms. While 14xy and just a regular xy are similar to each other, but 14xy is not similar to either of the first two, and neither is xy. The first two do not have a y. The second two do. So they have to have exactly the same variable part. Another definition, a term we're going to use a lot, is the least common denominator, LCD. The least common denominator for a set of denominators is the smallest, so least, number divisible by all the denominators. So in common, it's the smallest number that is divisible by all the denominators. Let's take a look. For example, if we wanted to add 2/3 and 7/8, we'd first find a common denominator. So I would list the multiples of the largest denominator. 8 is bigger than 3, so I'm going to list the multiples of 8. 8, 16, 24, 32, 40, 48. I could keep going, but usually that's enough. Choose the first one in this list that the smaller number, 3, goes into. So 3 does not go into 8 evenly. 3 does not go into 16 evenly, but 3 does go into 24 evenly. 24 is a multiple of 8. 24 is a multiple of 3. So this is your least common denominator. So we want to use that technique that we saw in the first lecture where we rewrite with a common denominator. So I'm going to take 2/3 And I want a denominator of 24, so 3 times 8 is 24, which tells me I have to multiply my numerator by 8 as well. 2 times 8 will give me 16. So I've rewritten 2/3 with the common denominator of 24 as 16/24. I'm going to look at my second fraction, 7/8. I want to rewrite it with the common denominator of 24. So I know that 8 times 3 is 24, so I have to multiply 3 by the numerator as well. 7 times 3 is 21. I've now rewritten 2/3 plus 7/8 with a common denominator of 24. That is now 16/24 plus 21/24. And to add fractions, we keep the denominator the same because this is telling us how many in a whole. There's 24 units that make up a whole. And the numerators tell us how many of each of those we have. 16 plus 21 gives me 37 of size 24th. So 37/24. A couple of identity properties. There exists a unique number 0 such that for any real number a plus 0 equals a, and 0 plus a equals a. I basically just told you that if you add 0 to a number, you get that same number back. And you already knew that. Did you know that it had a name? That's the additive identity. 0, the additive identity. The multiplicative identity is the real number 1. Because if you multiply any number a times 1, you get a back again. And remember, it doesn't matter which order we multiply by, the commutative property. 1 times a equals a, or a times 1 equals a. The identities are going to help us with the inverse properties, the additive inverse. For each real number a, there exists a unique real number negative a that gives me 0. In other words, opposites, a and its opposite negative a, always add to be the additive identity. Multiplicative inverses. For every real number a except for 0, there exists a unique real number 1 over a, such that when we multiply a times 1 over a, we get 1. So what is this? This is a number a, and this is its reciprocal. So a number multiplied by its reciprocal gives us the multiplicative identity. This is it for section 1.2.